Okay, this is a video lecture for Math 110, Mathematical Applications. And this video lecture is for Wednesday, April 8th. And the topic for today is sequences and series. Okay, what's the definition of a sequence? Sequence is basically a pattern of numbers listed in a prescribed order So a sequence is a pattern of numbers listed in a certain order, and a series is the sum of a sequence. Series is the sum of a sequence. And let's consider a simple example of a sequence. Consider this as a sequence. Okay, this is a simple sequence, and this is an infinite set of numbers. The dot, dot, dot indicates the set of numbers goes on forever. Okay, and perhaps you guys can already see the pattern. There's a pattern underlying these numbers. But I'll let you guys think about what that pattern is. So you can have finite or infinite sequences, and we can talk about individual terms of a sequence. So for instance, A1 equals 1. This is A subscript 1, okay? This is a subscript to A. A sub 1, that indicates the first term is 1. Okay, A subscript 2 is 1/2. So A subscript 2 means the second term is 1/2. Okay, A subscript 3 is 1/3, and so on. You could write out each one of these terms. You could label each one of these terms. Often we refer to the nth term. The nth term is referred to as A subscript n. And n here is called an index. So for instance, for the first term, n equals 1. For the second term, n equals 2. For the third term, n equals 3, and so on. So n is an index that basically labels which term you're talking about. And then A sub n tells you the value of the nth term. So for instance, A sub 1 is 1. A sub 2 is 2. A sub 5 is 1/5. Excuse me, A sub 2 is 1/2. A sub 5 is 1/5. Okay? And we can refer to the nth term for a sequence as A sub n, where again, n is the index. Let's consider an example of a sequence. Often, this is an example of a sequence where we listed out individual terms. Other times what will happen with the sequence is you're given some formula which gives you the value of the nth term. And as an example, we can consider the sequence generated by this formula. A sub n equals n squared minus n. This formula generates a sequence, okay? And we can actually write out the terms of the sequence. So if we're interested in what the first term is, A sub 1 is the first term. What this means is, this means the index n is 1, the index here is 1. We want to plug 1 in where we see n, where we see the index, to figure out what the term is. So we get 1 squared minus 1, okay? That equals 1 minus 1 equals 0. So the first term of this sequence is 0. And then we can calculate successive terms. A sub 2, here the index is 2, so we plug in 2 for n. We get 2 squared minus 2, okay? 2 squared is 4, so we get 4 minus 2, and we get 2. So the second term of this sequence is 2. We can go on and figure out the third term. You see the pattern here. To figure out the third term, A sub 3, we plug in 3 wherever we see n. So we get 3 squared minus 3, okay, this equals 9 minus 3, which equals 6. Okay, that's the third term. Let's calculate one more. Let's do the fourth term. We plug in 4 for n. We get 4 squared minus 4. Okay, 4 squared is 16 minus 4 is 12. So now we've determined the first 4 terms of this sequence. We could go on forever. We're not going to do that. It gets tedious. but we could write this sequence out. If we wanted to write out term by term, the first term is 0, the second term is 2, the third term is 6, the fourth term is 12, and this goes on forever. Okay, this is a sequence. This is the sequence generated by this formula. So you might be given a sequence of numbers. You might also be given a formula which generates a sequence of numbers. Okay, let's talk about a series. What does a series mean? Okay, a series is the sum of a sequence. So let's talk about a series. I lost my little sequence up here, but if you remember, I should have kept that here. Let me write it on the side. An equals n squared minus n. We figured out the terms of the sequence go like 0 to 6, 12, and so on. Okay, let's talk about series. Okay, series are usually indicated with an S with a subscript. And S sub infinity, what this means is, it means this is the sum of all the terms of your sequence. So S sub infinity equals A1 plus A2 plus A3 plus A4 plus dot 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 plus A to the n plus dot 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 out to infinity. So F sub infinity means sum up all the terms of your sequence. In this particular case, for this example, S sub infinity equals 0 plus 2 plus 6 plus 12 plus all the rest of the terms. Now see if you can guess what the sum of this series is. This particular sequence, what's the sum of it? Well, the answer, if you're thinking, well, gee, it's going to be infinity, you're right. So the sum of all the terms of the sequence is infinity. Okay. So that's an interesting case. But depending on you might think, well, what's the point then? If it's always going to be infinity, why even try to sum them up? There are some sequences where the sum of all the terms is not infinity. Let me give you guys another example. So this is one example. This is an example. Let me give you guys another example of a sequence. Okay, another example of a sequence is this sequence: 1, 1/2, 1/4, 1/8, 1/16, 1/32, and so on. This is an example of another sequence, okay? If we sum up all the terms of this sequence, okay, if we sum them all up, we get 1 plus 1/2, plus 1/4, plus 1/8, plus 1/16, plus 1/32, plus out to infinity, okay? Now, you might also think here, well, this is going to be infinity too, right? Because we're adding up we have an infinite number of terms we're adding up, okay? But the truth is, this actually equals exactly 2. The sum of all these terms equals exactly 2. Now you might wonder, how can we sum up an infinite number of things, of numbers, and not get infinity? How can we sum up an infinite number of numbers and get exactly 2? Well, the answer is, it's one of those kind of puzzles of mathematics. The answer is, each of these terms is getting progressively smaller. And so, even though we have an infinite number of terms, each term is getting smaller. So it so happens the sum of all these terms, all infinite number of terms of the sequence, is exactly 2. Okay, that's kind of weird. Don't, think about it. Don't worry too much about it. It's one of those puzzles of mathematics. Infinities are funny things. We don't have a good intuition for them. Okay. I want to consider what are called partial sums. I'm going to consider some partial sums here. Partial. Okay, partial sums. And again, I'm going quickly in these videos to keep the time down, to keep the upload time small, so you can always replay these videos or pause them or repeat sections. Let's talk about partial sums. The infinite sum of a sequence is all the terms added up. The partial sum of a sequence is where you sum up just a certain number of terms. You don't sum up all the terms. Specifically, S sub n. S sub n means what you do is you sub up A1 plus A2, you add A3, and so on, dot, 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 plus A to the n, and you stop at A to the n. Okay? So with a partial sum, you don't sum up all the terms of your sequence. you sum up just a finite number of them. For instance, I can calculate, as an example, I can calculate for this example, this is example 1, this is example 2. For example 1, I can calculate s sub 4. Okay, I can calculate s sub 4 here. What I do is I take the first 4 terms of the sequence. So I do 0 plus 2 plus 6 plus 12. Okay, and if I add up the first 4 terms of this sequence, I get 20. Okay, so the partial sum of the first 4 terms of the sequence is 20. I can also calculate the partial sum of this sequence. So if I do s sub 4, if I sum up the first 4 terms of this sequence, I get 1 plus 1 half plus 1 fourth plus 1 eighth. Okay, and in this case, what we want to do is find a common denominator here. Was I doing a different example? No, we'll do this. We can sum up all these terms, and I was going to do a different example, but we'll do this example. This is 8 over 8 plus 4 over 8 plus 2 over 8 plus 1 over 8. If we add all these, I found a common denominator of 8. If I add all these numbers up, I get 12, 14, 15 over 8. So the partial sum of the first 4 terms of this sequence is 15 over 8. So often it's useful to calculate a partial sum versus the sum of all the terms. Okay, that has to do with partial sums. I want to consider one more topic here, one more type of sequence. But I need to go check something on my computer, so I will be right back. I'll be back in 30 seconds. Be right back. Okay, I'm back, and what I want to talk about is something called a recursive sequence. Okay, I'm going to talk about a recursive sequence. Recursive sequence. What is a recursive sequence? I'm just going to say this in words. It's a sequence where the nth term of your sequence, where a sub n is calculated based on previous terms, such as a sub n minus 1, a sub n minus 2, and so on. So a recursive sequence is a sequence that instead of where you're given a formula, instead of being given a formula like a to a sub n equals n squared, this is not a recursive sequence because you calculate each term based on the index n. So instead of being given this, a recursive sequence is calculated where a sub n is calculated based on the previous terms and not the index. Let me give you guys an example. Okay, so here's a good example of a recursive sequence. Okay, this is my sequence a sub n equals 3 times a sub n minus 1. Now n minus 1 again is a subscript to a minus 1. Okay, and the thing about a recursive sequence is you need to be given the first term as well. So it's not good enough to be given an equation like this. You need to be given an equation like this. And to get things started, to get things rolling, you need to be given the first term of your sequence. So you need to be given a sub 1. In this case, a sub 1 is 1. Let's consider this example. This is a recursive sequence because each term is calculated based off the previous term and not off the index. And we're given the first term. Okay, well, how do I calculate my terms? What is a sub 1? A sub 1 is simple for a recursive sequence. It's just the first term, so that's easy. A sub 1 is 1. Let's calculate a sub 2. How do I calculate a sub 2? Well, I calculate a sub 2 based off the previous term. So a sub 2 equals 3 times the previous term. In this case, 2 is my index n. So what's the previous term to 2? Right? The previous term to 2 is a sub 2 minus 1 minus 1. So this equals 3 times a sub 1. The previous term to a sub 2 is a sub 1. So we get 3 times a sub 1 minus 1. Well, what is a sub 1? We already know it. It's 1. So this is 3 times 1 minus 1. And this equals 3 minus 1 equals 2. So the second term, so a sub 2 is 2. Let's calculate a few more. What is a sub 3? Okay. A sub 3 is equal to 3 times the previous term to a sub 3, right? The previous term to a sub 3 is a sub 2 minus 1. Well, guess what? We know a sub 2. We just found a sub 2. So we can do 3 times 2 minus 1 equals 6 minus 1 equals 5. A sub 3 is 5. Let's do one more for a recursive sequence. A sub 4 will equal 3, using my formula, 3 times the previous term to a sub 4, which is a sub 3, okay, minus 1. We just found a sub 3 is 5, so this term is 3 times 5 minus 1. And 3 times 5 minus 1 is 15 minus 1 equals 14. So a sub 4 is 14. And we could go on, we could calculate a sub 5, a sub 6. We're not going to do that. Keep in mind with the recursive sequence, the idea is it's kind of like a bootstrap method where basically any term you calculate is based off the previous term. And you have to be given the first term to get things started. So you calculate the first term, based off the first term you calculate the second term, based off the second term you calculate the third term, and so on. Okay, that's a recursive sequence. Okay, you also, it's possible to have factorials in a sequence. Let's just consider a simple example. Let's consider an example with factorials. If you guys remember our fun factorials, a to the n over 1 over n factorial. If you guys remember factorials, and this doesn't mean get excited, it means calculate a factorial. You could have an expression that gives you a sequence in terms of a factorial. This is a different topic than recursive sequences. To calculate a1, you do 1 over 1 factorial, which equals 1 over 1, which equals 1. A sub 2 equals 1 over 2 factorial, which equals 1 over 2 times 1, which equals 1 half. A sub 3 equals 1 over 3 factorial, which equals 1 over 3 times 2 times 1 equals 1/6, and so on. You could go down the line. The moral of this is it's possible to have a sequence given in terms of factorials, and you can calculate the value of the sequence based on our factorial. Okay. I want to, as the last topic is, I want to consider a fun sequence. It's called the Fibonacci sequence. You may have heard of this. The Fibonacci sequence. And the Fibonacci sequence is given by this series of numbers: 1, 2, 3, 5, 8, 13, 21, and so on. Okay, this is the Fibonacci sequence. Can anyone guess the pattern here to this sequence? Okay, the pattern is, if you take these first two numbers, to get the third term, you add the previous two numbers. Okay, so that's how we get 3. How do we get 5? To get 5, we add the previous two terms. 2 plus 3 is 5. To get 8, we add the previous two terms. 3 plus 5 is 8. To get 13, we add the previous two terms. 5 plus 8, get 13. The Fibonacci sequence is a recursive sequence. And if you try to guess the formula here, the formula is a sub n equals a sub n minus 1 plus a sub n minus 2. And a sub 1 equals 1, and a sub 2 equals 2. I'm not going to test you on this. Don't worry if you don't fully understand this. I'm not going to give you any problems like this. But it's a fun sequence to know about. The Fibonacci sequence actually appears in seashells and other things in nature. But the Fibonacci sequence is a recursive sequence where you get each term is obtained by adding the previous two terms together. That's a fun sequence. This concludes our video lecture. I will see you guys on Wednesday, April 8th, and we can go over these topics, do some more practice problems, and go over the homework. Oh, there's no homework due on Wednesday because you guys have a test on Monday. So there's no homework due. We'll just do some practice problems relating to sequences and series. All right, see you then.